Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 10C assignment. Okay, so we'll start here with number one. List using set notation the sample space for twirling a square spinner labeled A, B, C, and D. Okay, so to using our set notation means we want to use our little brackets here. And we're going to just, in the brackets, list out the possible outcomes. So that's just going to be A, B, C, and D. Okay. B, list in using set notation the sample space for spinning a wheel with sectors labeled with the numbers 1 to 8. So now we will do the same thing. Brackets 1, 2, 3, 4, 5, 6, 7, and 8. And that is our sample space for these. Okay. All right, number 3, 1 ticket's drawn from a box containing tickets labeled with the numbers 1 to 16 inclusive. Okay, write down the sample space U. So for that, we are going to simply write down, I would do U equals, and then we do our brackets here. Now we're going to list off all the numbers 1 through 16. And since it says inclusive, that means we include 1 and 16 as well in this group. Okay? So that is our U for, remember, that's a universal set. Okay? List the outcomes of the following events. A, the ticket's number is a multiple of 4. So the outcomes we're going to want to list the same way using our set notation. So A, all of our multiples of 4 are going to be this: 4, 8, 12, and 16, right? So we just simply list all of those in set A. Okay. B is the ticket number is a perfect square. So B will be 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 16 is our perfect square. 1, 4, 9, and 16. Okay. All right, that's 3. Let's move on to number 5. Illustrate on a tree diagram the sample space for tossing a 5-cent and a 10-cent coin simultaneously. So here's what I would do. So first one we're going to do is say the 5-cent coin. We can either, on that 5-cent coin, we can either flip heads or we can get a tails, right? And then now the 10-cent coin, we'll just say, I just like to think of this as going to be the first thing we're going to do, and this is going to be the second thing we're going to do. So now the 10-cent coin is going to be this. If we got heads on the 5-cent coin, we can either get heads or tails on the 10-cent coin. If we flip tails on the 5-cent coin, we can still get either heads or tails on the 10-cent coin. Okay, so this is what our tree diagram illustrate on a tree diagram the sample space for a 5-cent and a 10-cent coin simultaneously. Simultaneously means at the same time, but really, like, the easiest way to do these is think of, I'm going to do this first and then I'm going to do that second. It just, for most people, it makes a lot more sense. Okay. All right. Number 6, from the whole numbers 1 to 7, Adam and Bill each select a number. Illustrate the sample space on a 2D grid. Okay. Circle the outcomes in the event Adam and Bill's number are the same. So 2D grid is, 2D grid is simply this. We're just going to make ourselves basically like a little table here, right? Okay, and let's say this is going to be Adam. He can get a 1, 2, 3, 4, 5, 6, or 7. And then this is going to be Bill here. And he can also get 1, 2, 3, 4, 5, 6, or 7. Okay? You can set it up you could set this up any number of different ways. Oftentimes in the book, you're going to see it set up this way. Adam and Bill Bill and Adam, doesn't matter. You can set this up really however you want, because it's going to, however you set it up, is still going to help us figure out how to calculate these problems. Okay. So what we want to do is we want to also in here put dots for all these possible outcomes, right? So like say this dot right here is where Adam rolls a 7. Let's see, or selects the number 7 and Bill selects the number 1. Okay, so we're going to put dots throughout all of those. Okay, so it looks like this. All right, and then it says circle the outcomes in the event where Adam and Bill's numbers are the same. So Adam and Bill both roll a 1 here, both pick a 1, pick a 2, 3, 4, 5, 6, and 7. So that would be where they pick the same numbers. Okay. All right, that's all we have for the 10C problems. If you have any further questions, please feel free to ask. Thanks.